why the universe may be running on borrowed laws. It began with discrepancy so small it was almost ignored. A mismatch between what the universe should allow and what it actually does. But inside that gap, physics uncovered a disturbing possibility. At first, the discrepancy looked like noise, the kind of rounding error that disappears with better instruments or cleaner equations. Physics has always tolerated tiny mismatches at the edge of precision, trusting that deeper symmetry or undiscovered particles would eventually smooth them out. But this one refused to go away. It persisted across experiments, calculations, and scales, quietly undermining assumptions that had stood for generations. To understand why this matters now, we need to look at how physical laws were once treated. Constants were fixed. Forces behaved the same everywhere. Time, space, and matter followed rules that did not change. The universe was stable because its laws were permanent. That permanence was not just a scientific assumption. It was a philosophical anchor. If laws were eternal, then reality itself had a fixed backbone. That confidence began to erode as measurements grew more precise. Constants that should have been exact showed subtle tension. Values appeared finely balanced, as if tuned to avoid collapse. Slight deviations would erase stars, atoms, or chemistry entirely. The universe existed, but only barely. What once felt robust now appeared precariously balanced on narrow margins. At first, scientists searched for missing explanations, hidden particles, undiscovered forces, deeper symmetries that would restore inevitability. But each solution introduced new problems. The equations worked only if values were improbably specific. Coincidence became explanation, and explanation began to feel unsatisfying. Then a radical idea surfaced. What if the laws we observe are not fundamental? What if they are temporary arrangements, effective rules that hold only under current conditions? In this view, the universe is not governed by eternal laws, but by borrowed ones. Local rules that emerge from deeper structures, stable for now, but not guaranteed forever. Like ice-forming patterns that vanish when temperature shifts, the laws themselves might be phase-dependent. Expressions of underlying conditions rather than unchanging truths. This reframed everything. Constants became outcomes rather than inputs. Laws became approximations rather than foundations. Stability became contingent rather than guaranteed. Physics stopped describing a universe carved in stone and started describing one balanced on circumstance. And once physics admitted that its rules might be provisional, the universe stopped looking permanent. It began to look like something that could, under the right conditions, change the way it behaves entirely. As physicists followed this idea deeper, evidence began to align in unsettling ways. In extreme environments, the universe behaved differently. Near black holes, time stretched beyond familiar limits. At cosmic scales, expansion accelerated in ways existing laws struggled to explain. At quantum levels, forces blended and separated depending on energy, as if identities were negotiable rather than fixed. These were not violations of law. They were signs of transition. The rules changed smoothly as conditions change, suggesting that what we call laws might be phase behaviors rather than absolutes. What held in one regime dissolved naturally in another, without contradiction. The conflict emerged when models showed that many constants only appear fixed because the universe cooled into its current state. Early on, forces may have been unified. Values may have shifted as symmetry broke and structure emerged. What feels permanent now could be a snapshot, frozen by circumstance rather than guaranteed by necessity. This reframed cosmic history. The universe did not begin with its present laws. It arrived at them, and if it arrived once, it could arrive somewhere else again. Physicists explored theories where laws emerged from deeper mathematical landscapes, vast spaces of possible rules, with universes settling into stable regions the way matter settles into low-energy states. Ours happened to land where complexity was possible, not because it was chosen, but because unstable arrangements do not last long enough to be observed. The emotional weight of this idea was heavy. Stability was no longer guaranteed by principle. It was earned through balance. The universe survived because its borrowed laws held long enough for structure to form, stars to ignite, and complexity to unfold. And this raised a quiet fear. If conditions shift far enough, the rules could change again. Not suddenly, but inexorably as environments drift. No catastrophe, no rupture, just gradual incompatibility. The universe might not break its laws. It might simply outgrow them. The conflict reached its peak when physicists asked what would happen if borrowed laws expired. Not in catastrophe, but through gradual drift, a constant shifting just enough to alter everything built upon it. Models revealed a chilling sensitivity. Slight changes in fundamental values could unravel chemistry. Stars might burn differently. Atoms could lose stability. Life, as structured today, would not adapt. It would dissolve, not violently, but inevitably. This was not science fiction. The math was precise. The margin for change was narrow. The universe appeared resilient, but only within tight bounds. Outside them, complexity vanished quickly and completely. The deeper concern was timing. If laws can evolve, they do so slowly across cosmic scales. No alarms, no warnings, just a quiet departure from the conditions that allow structure. The universe would not end. It would transform into something incompatible with what came before. This reframed existential risk. Humanity often fears sudden collapse, but borrowed laws imply something subtler. A future where the universe continues, but without us, not because of destruction, but because the rules no longer support our existence. The emotional weight peaked with a realization that cut deeper than apocalypse. Permanence was never promised. Stability was a phase. Life exists in a window, held open by temporary alignment. The universe did not guarantee meaning. It permitted it, and permission, once given, does not have to last forever. The resolution did not arrive as fear, but as perspective. Borrowed laws did not make the universe fragile. They made it precious. Stability was not entitlement. It was opportunity. Physicists reframed their understanding of permanence. Laws were no longer commandments etched into reality. They were conditions that allowed structure persist. And conditions, by definition, can change. This did not diminish science. It deepened it. The goal shifted from discovering eternal truths to understanding why certain truths last as long as they do, why balance holds, why complexity survives inside narrow windows. For humanity, the implication was quietly profound. Existence is not guaranteed by the universe. It is allowed by it. Life unfolds not because the cosmos favors it, but because for now, the rules permit it. That realization carries responsibility. When stability is temporary, meaning gains urgency. Creation matters more when it is contingent. Choices echo louder when time is finite. The universe may be running on borrowed laws, but within that borrowing, extraordinary things happen. Stars ignite, minds emerge, questions are asked. Physics did not uncover a countdown. It uncovered condition, one that invites humility rather than despair. Because if the laws we live by are temporary, then what we build under them becomes the only permanence we ever truly have. Sometimes the smallest shift in perspective becomes the beginning of a new future.